So in the last video, we learned how to make all of these calculated columns for our data set for the inclined glider lab, for the inclined air track lab. And so we've got all these columns for the time and position. We converted the time from frames to seconds. We squared the time. We found the displacement and the time interval so that we could calculate the velocity. And then we calculated a middle position as well, or sorry, a middle time as well as a middle position column for our glider. Now what we're going to do is make some graphs. First thing you need to know is, just like in class, you don't turn in graphs on the same page as data, so you need to make a different page for each one of your graphs. So in Logger Pro, up here we have the page menu, and we want to add a page. And you can title it if you want. So I'm just going to title this position versus time graph. You want it to be a blank page, and then press OK, and up comes the blank page. We want to put a graph on that page, so I'm going to go to the Insert menu, insert a graph, and Logger Pro has no idea what kind of graph I want, and so I'm going to make sure that it comes out right. This is a middle position versus time graph, which is really not very useful. And you'll see that there's no title on the graph. It's kind of scaled a little bit off, and there are no point protectors. Instead, these are actually lines that connect the points together, so that's not very useful either. So to fix things in Logger Pro, just like on the data table, you double-click on the column heading to change things. On the graph, you double-click on the graph. So I'm going to double-click here on the graph, and up comes my graph options. First, here in the graph options, I'm going to change the title of the graph. I want a position versus time graph. Also here, there's all these checkboxes. Really, you don't need any of them checked, but it's really important that you do not check connect points, and that you do check point symbols. Those are the point protectors that are on the graph. Then we go to the axes options window. You don't need to type anything here. This is basically set up so you have the y-axis over here and the x-axis over here. We're never going to use anything on the right-hand side of the y-axis. So here's a list of your options. You can see that middle position is what's checked here. We don't want middle position checked, so I'm going to uncheck that. I want position in centimeters. And then here I'm going to check on auto scale from 0. And then I want time here on the x-axis, make sure that's the time in seconds, and I want to auto scale from 0. And so now when I hit OK, I get a graph that looks like this. Notice that there's no best fit curve or line on there, so I'm going to put a best fit curve there. I can do that from here. This little button here says curve fit, or if I forget what that button is, if I want to analyze the graph, then I want to put a curve on it, so I'll choose curve fit. So either the menu choice or the button will do this. So here's my list of choices. We talked in class about how this is a parabola. Parabolas have quadratic equations that go with them, so I'm going to choose quadratic fit. And then you hit try fit, and it will give you a whole bunch of coefficients that is figured out are the best for your data. Once in a while, something weird happens where you'll hit curve fit, and you'll hit quadratic, and hit try fit, and they'll tell you it can't find, you don't have enough points selected. What they mean is they want you to drag across this graph. So if you kind of drag across the graph and then hit try fit, then it should work. So in case you have that problem at home, try that. And now we get this little box. This is handy for looking at these are the coefficients of the equation. And now that we understand the relationship between position and time, hopefully you understand what these coefficients actually tell you about the motion of the glider. This negative 18.6 goes with the t squared, this 110.8 goes with the t, and this 1.983 goes with c, so or is basically the position 0 of the glider. So our next graph is going to be, well, in the past we've made a position times squared graph to linearize this, so let's go ahead and do that. I'm going to add a page again. I'll title it position versus time squared. Again, this is completely optional. You don't need to title the pages if you don't want to. It's a blank page. I insert a graph. Puts up the wrong graph. At least this time, most of the things are, at least this time it has point protectors. I double click. It opens up to axes options. I'm going to have position, uncheck the middle position, auto scale from 0. This time I want the time squared, auto scale from 0. Go to the graph options. I want the title to be position versus time squared. Point symbols is checked, connect points is not checked. And then I click OK. And now it does not give me that straight line graph that we've been expecting from position times squared graphs. And the reason is, with the wheel, we had the wheel start from rest. And this graph position and time are only directly proportional when the wheel starts from rest. And so this graph here will not be linear in this case. And in fact, you can't even really fit a curve on here, so we won't worry about that. Our next graph will be velocity versus time. So again, add a page. I'm going to title it velocity versus time. Click OK for my blank page. Go to the insert menu, insert a graph. Not the graph I want. Double click on that graph. I want the velocity. Velocity, auto scale from 0. Remember that that velocity was calculated as an average velocity, and the average velocity is only the instantaneous velocity at the middle time. So I need to choose my column for middle time on the x-axis. Make sure you're auto scaling from 0. Click OK. And here's my data. You can see that that is a line, so I'm going to put a line of best fit on there. You can put a linear fit on your graph. You can choose it from the curve fit. It's one of the options there, but you can also just click it directly here, linear fit, and it will put a linear fit on there. If you forget what this button is, go to the Analyze menu. Linear fit does the same thing. And now it tells me my slope here and my y-intercept for my graph. One thing that I forgot to tell you guys, make sure you save early and often. We're going to make one more graph of velocity versus position graph. So I'm going to add a page. Click OK. It's a blank page. Go to Insert. Insert the graph. Stretch it out. Double click to change things. Velocity here versus, and just like velocity was only correct at the middle time, the velocity is also only correct at the middle position only. We talked in class about how that's not really true either, but at least it's close. Go to graph options, velocity versus position. And again, make sure point symbols is checked, connect points is not checked. Click OK, and there's my graph. That's kind of weird. It's a sideways parabola. Okay, this is a sideways parabola. We talked in class about how this is not a function. You can't, we can't assign one of the functions on it for curve fit because this does not pass that vertical line test. There are two y values for every x value on this graph. In other words, at any position on that track, the glider was there twice, once moving upwards and once moving downwards. We can actually try to linearize this graph, and we'll look at this in class on Monday. We can linearize this graph by squaring the velocity. So remember when we did the wheel lab, we squared the times to linearize a upwards opening parabola. Well, with a sideways opening parabola, we're going to try squaring the velocity and seeing what that does. So I'm going to go all the way back to my data page. So here's my different pages. Page 1 had my data on it. I'm going to make one more column for the velocity squared. So that's a calculated column, new calculated column. Velocity squared. Oh, sorry about that. You can't see that. V squared centimeters squared per second squared. And for my expression, I'm going to just take the velocity column, shift 6 to give me the caret symbol, and 2. So that's velocity to the second power. I'm going to make it black and change the point protector to an empty circle. And I'm done. Let's stretch that out a little bit. Oh, and I forgot to take the decimal points off, sorry. We go to the options, change the display precision to 0. And now we have no decimals there after the velocities. So let's make one more graph. So here's my velocity versus position graph. Let's make one more graph. We'll go to add a page. Velocity versus position squared. I'm sorry, velocity squared versus position. Blank graph. I'll insert a graph. Ooh, it's close. It gave me a velocity squared versus time graph. I'll double click. I've got velocity squared checked there. I want this versus the middle position. Come back here. Velocity squared versus position. Point symbols is checked. Connect points is not checked. Hit OK and see how it looks. And I've got a nice linear relationship there. I'll put a linear fit on there. And now I've got my slope and my y-intercept of that graph. This is kind of an interesting graph, and we'll talk about this in class on Monday. Now, I'm going to save this real fast. When it's time to print, you want to do a couple things. First, go to the page setup in the file menu and make sure that you're printing in landscape mode so that all your graphs take up as much space as possible. Then, unfortunately for this lab, printing the data table is kind of hard. We've got a couple options. You can either, on the data table page, if I go to options, table options, I can change the size of the font so that it's smaller and you can fit more of your data in. And that way when you print, almost all of your data will fit. And honestly, if it's just like here, if I just miss a couple lines, it's not really that big a deal. But you probably want to get it. So I kind of recommend you do this. Another thing you can do is cut and paste your data into Excel or some other spreadsheet and print it that way. You'll have some more formatting options there. But don't worry too much about this. This data table is just one of the bigger data tables we're going to have this year. When you print graphs, similarly, when you print the graph, you're going to go to the graph and hit print graph. Sometimes when you hit print, you can print everything with one click, but a lot of times you might see this at home. Your graphs will print without any of the x-axis on there and missing the time and the seconds, and it doesn't look very good. So really, it works out better if you get this graph up and then hit print graph. The little dialog pulls up. Type your name in there so you know whose graph it is. Maybe something about which lab it is, and hit OK. And then your dialog box will pull up so they can print your graph. So for Monday, hopefully you'll bring in pages with your graphs that look like this. And then we can get talking about the mathematical analysis and the meaning of these slopes and y-intercepts on these graphs. If you're having any trouble, please bring your file in on a flash drive or email the file to yourself so that we can work on it in class on Monday.